Hello dear students, you already know that Lenard's experiment. By using this Lenard's experiment, we just observe the photoelectric effect. It means in Lenard's observation of a photoelectric effect, suppose we consider that a two metal, one is connected to a negative terminal of a battery, another one is positive terminal of a battery. When UV rays is incident on a cathode, then what happens? So this metal continuously emits photoelectrons. So these electrons are moved towards the anode. It means a collector, and this collector collect the photoelectrons. Then we get a photoelectric current. Yes. Suppose if a polarity of a battery changes, it means negative terminal of a battery is connected to a anode and positive terminal of a battery it is connected to a cathode. Then what happens? So here we don't get any photoelectric current. It means if you supply negative potential difference to this collector, or we consider that anode, then so this potential makes a photoelectric current becomes 0. So this electric potential we consider that negative potential. As if the potential, it means a negative potential is applied to a anode, it means a collector. So this one is makes a photoelectric current becomes 0. So this one is a stopping potential. Yes, okay. So this stopping potential is related to intensity, and the stopping potential is related to frequency. It means the relation between stopping potential and the intensity of incident radiation and the stopping potential and the frequency. It means a relation between stopping potential and the frequency. Today we will discuss about these two concepts. Okay, the first one, the stopping potential. It means negative potential is connected to a anode or a collector, so it makes a photoelectric current becomes 0. Okay, so here, so this stopping potential is, suppose here we consider that V naught. So V naught we consider that stopping potential or negative potential. Stopping potential, or we consider that a negative potential. So this one is a stopping potential. Yes, it's having a particular value. It is mainly depends upon frequency, and it is independent on intensity. Yes. So first one, you already know that photoelectric current versus intensity graph. Photoelectric current versus intensity graph. Okay, so here along x axis we consider that intensity, and along y axis photoelectric current. Suppose the intensity increases, the photoelectric current becomes increases, because intensity increases, the number of production of photoelectron is also increases. So this reason, so photoelectric current is also increases. The same thing here we consider that frequency versus kinetic energy. Yes, so this one is a kinetic energy of a photoelectron, and along x axis we consider that frequency. Yes. Okay, so here whenever the frequency of incident radiation increases, then kinetic energy of a photoelectron is also increases. Yes, the frequency of incident radiation increases, then kinetic energy of photoelectron is also increases, and here we consider that a nu naught. Why here we consider that nu naught? Because nu naught is nothing but a threshold frequency. Nu naught is a threshold frequency, and this gap represent minimum frequency, it means below the minimum frequency, and a nu naught is a minimum frequency. Afterwards, whenever the frequency of incident radiation increases, then the kinetic energy of a photoelectron is also increases. So, this graph represent kinetic energy versus frequency and photoelectric current versus intensity. It means the intensity is directly proportional to the photoelectric current and the frequency is directly proportional to the kinetic energy of a photoelectron. So, today we will discuss about stopping potential versus kinetic energy, intensity, and stopping potential versus frequency of incident radiation. Okay, so here so along x axis we consider that a stopping potential, and here y axis we consider that the first one photoelectric current. So, x axis is potential difference and y axis we consider that a photoelectric current. Okay, so here, so this suppose we consider that this one is origin, it means a 0 electric potential, and in this side we consider that a positive potential difference, and in this side we consider that a negative potential difference is our potential, and here we consider that positive potential or potential difference, and this one is a origin. So, here we consider that a 0. Okay. When a negative potential is applied or connected to the collector, then the photoelectric current becomes 0. The same thing, so here negative potential increases, in this side negative potential increases and here positive potential increases. Whenever the positive potential is applied to Lenard's experiment, then what happens? So, photoelectric current becomes increases. But here when a negative potential is increases, then what happens? Photoelectric current goes on decreases, finally it comes to 0. The same thing here, the first one we consider that intensity is whenever if intensity increases, photoelectric current becomes increases because rate of production of a photoelectron increases. So, this reason here we consider that one particular intensity of a radiation. Okay, so here we consider that a particular intensity, suppose we consider that I1, and here we consider that this one is a photoelectric current at particular intensity I1. Then afterwards negative potential is applied to the collector, then what happens? So, photoelectric current becomes 0 at a particular negative potential difference. Is negative potential applied to the collector, then what happens? Photoelectric current becomes 0. Suppose if we consider that a maximum intensity of a radiation I2 is when maximum intensity of a radiation, so here we consider that when intensity increases, then photoelectric current becomes increases. Okay, so intensity increases, so this reason photoelectric current is also increases. Then afterwards what happens? So, negative potential applied to the collector, then what happens? So, photoelectric current becomes 0. Yes, so here I2 is greater than I1, I2 greater than I1, it means intensity of I2 is maximum compared to I1. When intensity increases, so photoelectric current becomes increases. So, intensity decreases, photoelectric current, so that one is decreases. But here stopping potential remains same. Intensity increases, photoelectric current increases, but stopping potential remains same. So, this reason intensity is independent on a stopping potential. Intensity is independent on a stopping potential. Why? Because intensity increases, then photoelectric current increases, but a stopping potential remains same. So, this reason intensity is independent on a stopping potential. So, this one we consider that a V naught. So, this one is a V naught. Yes. Next relation we consider that a frequency versus a stopping potential. Frequency versus a stopping potential. Okay, you already know that whenever the frequency of incident radiation increases, frequency of incident radiation increases, then what happens? So, kinetic energy of a photoelectron increases. It means the speed of a photoelectron increases. When a speed of photoelectron increases, it means we apply maximum opposing force to this moving electron. Yes, suppose if we consider that, so this one is a photoelectron moving with the maximum kinetic energy, it means the maximum speed. We want to stop this motion of an electron, it means we apply maximum opposing force. Yes, so this reason here we apply maximum negative potential to stop the photoelectron motion, it means the motion of a photoelectron. We have to stop the motion of a photoelectrons. It means we apply maximum potential difference. It means a maximum negative potential. Okay. So, this reason here we consider that another one graph, frequency versus potential difference. Here also same thing. Suppose here we consider that this one is origin 0 and in this side we consider that a positive potential difference. And in this side we consider that a negative potential difference, and this one we consider that a photoelectric current, along y axis is photoelectric current. Okay, so here if you consider that different frequencies of a light, so different frequency, initially we consider that a minimum frequency, then afterwards maximum frequency. So these frequencies is always greater than a threshold frequency. Why here we consider that a greater than threshold frequency? Because below this threshold frequency we don't get any photoelectric current. So this reason, in this condition we have to consider that a maximum frequency. Maximum frequency, it means a greater than a threshold frequency. Yes, so here we consider that maximum frequency, it means a greater than a threshold frequency. Okay, so this one is positive potential difference, it means we consider that anode potential, and this one is a cathode potential, or we consider that a negative potential, and here we consider that a 0. Okay, so here whenever if you consider that a different frequency of a light, so different frequency of a light means a photoelectric current becomes same. Why photoelectric current becomes the same? Because a frequency increases, kinetic energy of photoelectron increases, but intensity increases, number of production of photoelectron increases. So this reason intensity directly proportional to the photoelectric current, but frequency directly proportional to the kinetic energy of a photoelectron. Okay, so this reason here we consider that different frequencies of light rays or radiation. Here we consider that first one is so this one is a particular frequency of light rays, it means greater than a threshold frequency. Okay, so here greater than threshold frequency, it means a negative potential applied to this anode, then what happen? So here, so photoelectric current becomes 0. Then afterwards, again if you apply a maximum frequency, so maximum frequency, if a frequency increases, the frequency increases, then kinetic energy increases, it means a maximum negative potential, it is used to stop this moving electrons. So this reason here, if a negative potential applied to the anode, then what happen? So photoelectric current becomes 0. Okay, so this one is also we consider that nu naught, and this one is nu naught 1, and this one is nu naught 2. Yes, and here another frequency, if you consider that another frequency, then what happen? Again the negative potential value increases. Suppose, so first one we consider that this frequency value is a nu 1, and this one is a nu 2, and this one is a nu 3. Whenever the frequency value increases, so kinetic energy increases, it means it's a required maximum negative potential. to make a photoelectric current becomes 0. Okay, so here nu 1, so first one, the nu 3 is a maximum frequency compared to nu 2 and nu 2 is a maximum frequency compared to nu 1. So this reason nu 3 is greater than nu 2 and nu 2 is greater than nu 1. It means nu 3 is a maximum frequency compared to this nu 2 and compared to nu 1, so nu 2 is a maximum frequency. So this reason, so corresponding potential difference we consider that so nu 3, and it means here we consider that a maximum negative potential. It means so this one is a nu 0 3 greater than nu 0 2 greater than nu 0 3. It means whenever frequency of incident radiation increases, then negative potential or cutoff potential value is also increases. Yes, so this radiation having a maximum frequency, it means it's require maximum negative potential to make a photoelectric current becomes 0. Again frequency increases. Again it means initially we consider that nu 1, its corresponding frequency we consider that nu 0 1. It means a minimum frequency. Then when frequency increases, then a negative potential value is also increases. So this reason, so this stopping potential, so stopping potential is directly proportional to the frequency. So stopping potential is directly proportional to the frequency, but intensity is independent on stopping potential. Frequency is depend on stopping potential. It means so stopping potential is directly proportional to the frequency, but intensity is independent on stopping potential. It means intensity does not depend on stopping potential. If intensity increases, but stopping potential value remains the same. If frequency goes on increases, then stopping potential value is also increases. Yes.